All right, let's talk driving force. So driving force is a concept that's sort of a bit convoluted, and a lot of students have trouble with it just because the way it's sort of presented doesn't really make sense at all. But we're gonna go ahead and try to break it down and make it super easy. And honestly, if you're still not getting it, on this video is probably all you're gonna need for it. It's also not like super high yield, so I wouldn't like stress out about it too much or go into it any more than this. Yeah, it's other than that, it's actually pretty simple. You just have to remember a couple things, and we'll just break it down step by step so that you basically don't miss any questions on this. So the first thing with driving force is what is driving force to begin with? So basically what you're trying to do is you have a VM value, which is going to be your given resting membrane potential. This is going to be given in the question stem. So whatever it is, if it's -30, if it's -50, if it's 50 itself, just use that value. That's going to be your VM value that you're given. The EM value, on the other hand, that's going to be a electrical potential for a specific ion. So if they give you chlorine or potassium or sodium or whatever it is, depending on what it is, it's going to change the value. But also it could be depending on the numbers that they give you in the actual question stem. If there are no numbers in the question stem, then the values that you're going to be given usually are going to be the constants for that. And we're going to see that in a second as well. So the first thing you want to do is you're going to be given the VM and the EM values, as we said. So let's go ahead and take a example problem and see how that's going to sort of work out. So the first one we're going to do is sodium. So that's going to be the inside of the cell, obviously. And we're going to say that the sodium concentration inside of the cell is going to be 14. And then we'll say the sodium concentration outside the cell is going to be 140. So basically, the first thing you want to do with this is you want to take the, and your VM that we're going to be given for this equation, or for this problem, is going to be -20 millivolts. Sorry about that. Okay, and the first thing you want to do is you want to calculate your Nernst equation. So the Nernst equation that you're going to have is going to be the EM is going to equal -60 over Z log in over out, meaning the concentration of the ion inside the cell versus the concentration of the ion outside the cell. The one thing you want to sort of watch out with this, though, this equation, and it's usually going to be like almost the same for everything, except when the Z value changes. And the Z value is going to change depending on the valency of your ion itself. So, for example, with sodium, its Z value is going to be +1. And the reason for that is because the charge on sodium itself is just +1. But if they gave you chlorine or something like that, then that would be -1. If they gave you, say, calcium, which has a +2 charge, then you would put +2 as your Z value. Lithium is going to be +3. Whatever it is, make sure that you plug that in. When we see later on, as far as like the driving force magnitude and like the negative and positive values and stuff they give you for that doesn't matter as much as this value right here, because this one is actually going to change your answer depending on if you put in the wrong value or not. So just make sure you watch out for that. Don't put the wrong values in. Make sure you're looking at what ion you're looking at, which actually leads us to our next step. So basically the next step you want to see is you want to see the charge differential between the inside and the outside of the cell at rest. So meaning at your -20 value of your VM value. So your VM value is going to be -20, which is your resting membrane potential inside the cell. That means that the inside of your cell is negative at rest. What you want to do next to find out the direction of your ion flow is going to be to look at the charge of your ion itself. So in this case, sodium. So sodium has a positive charge, right? And the inside of the cell has a negative charge. So basically from this, you can tell that the direction that sodium is going to be flowing is most likely going to be from the positive to the negative, since it's going to be towards whatever it's attracted to. Now in this case, if you had chlorine and it was negative on the outside, and the inside of your cell was negative as well, it's going to be the other way around. So basically you just got to watch out for that, and we'll go over a couple more examples with that. But basically that's going to give you your direction of flow. Don't look at all the vector stuff. You don't need it. This is probably not the right way to do this, but at the same time, you're not going to miss the questions. So just do it like this and you'll get it right. And honestly, like you're probably not going to use this ever again. So like, don't really worry about it. Just like, go ahead and get your points, leave. But anyway, so basically what you want to do with this is that's going to give you a direction of flow. So in this case, the direction of flow is going to be an influx because sodium is positive and it's going to be flowing towards the negative interior of the cell. So let's hold on to that for a second and let's go back and look at this. So now we had our EM value, which we were calculating out. So let's just straight up, all you have to do is you just have to plug in the numbers that you're given. So in this case, you're given the inside of the cell for for sodium to be 14, and the outside of the cell is going to be 140. So then whenever you solve this equation out, and you basically just plug it in on the calculator on ExamSoft, it's going to give you something along the lines of about negative 60 millivolts for your EM value for sodium. Positive 60 millivolts for your EM value for sodium. So basically, what does that tell you? Well, the next thing you want to do is we've already figured out the direction of flow. Now we just need to figure out the magnitude of the vector itself, so the magnitude of the flow. Honestly, the easiest way to do this by far is just to straight up draw a number line and to look at the difference between your EM value and your VM value. So basically what you want to do is you want to take your VM, which is your resting membrane potential, to your EM. So you want to take the VM to the EM, and that's going to give you your value for the actual magnitude of the flow. Don't really get caught up on like all of the like the stupid it's like a negative 60 or like positive 60 or whatever it might be. That's really not going to be tested as much. The influx versus the efflux, that's going to be tested, and then definitely like calculating out the magnitude of flow itself is going to be tested. But like as far as like trying to figure out whether or not it's like negative or positive, that's just going to confuse you. Like don't even worry about that. We never saw it show up. So it's probably not going to show up. So anyways, what you want to do with that is you just want to straight up draw a number line. We're going to say this is 0 millivolts right here. Okay, and we found our VM value to be negative 20, right? And we found our EM value to be 60. So basically, what you want to do is you want to take your VM value, which is negative 20, and you want to take it to the EM. So you want to take the VM to the EM. In this case, the EM is going to be 60 millivolts. So basically, when you take your VM to the EM, all you have to do to calculate out the values is just look at the raw difference between the two. So from here to here, you're going to have 60. And from here to here, you're going to have 20. Totally, once again, totally ignore all of the like stupid little like negative and positive value differentiate. There's no difference. Basically, you're just looking at that. You take 60 plus 20, and it's going to give you 80, and that's going to be your answer, basically. So then what you're going to get is 80 millivolts as your answer because you took 60 plus 20. And now, what was the other half of your answer? So 80 millivolts is the amount of is the magnitude of your answer, and then your direction of your answer is going to be the influx. So for this problem where they gave you this VM value, you found the EM value, you looked at the direction of the flow, and you found the difference, what your answer is going to be is it's going to be 80 millivolts influx. And that's how the actual answer choices will be presented on the exam. So that's what you're going to be looking for. You're not going to be looking for negative 80. You're not going to like, all you got to do is just do it this way, and you'll probably get it right every single time. Yeah. And the reason for this, by the way, the reason why you can sort of ignore the direction of flow. So say, for example, if we had potassium or something that's way more concentrated inside the cell than outside the cell, you're still going to, if the VM value is negative, it's still going to be an influx, which seems like stupid. Like, honestly, like, you think about it and you're like, wait, there's so much potassium inside the cell. Why is more potassium going inside the cell? And it's because the electrical gradient is going to be most likely stronger than your chemical gradient. So no matter what, make sure to look at that. That's the easiest way to figure out which way things are going to be going. So if you do that, you're going to get 80 millivolts influx. So this is the easiest way to do this. I swear, I promise. You're not going to get it wrong. But if you don't believe me, we're going to go over 2 more examples. And we're just going to use a couple different things to make sure that we cover all of the bases so that you don't miss any questions off of stupid little stuff. All right, so for the next one, we're going to be given lithium. Okay, so we're going to be given lithium as our ion. And we're going to be given a VM, which is going to be equal to negative 30. Inside the cell, our lithium concentration is going to be 14. Outside the cell, our lithium concentration is going to be 140. All right. So let's break this down step by step. So the first step that we want to do is we want to find our EM value, right? So we're given our VM value, and we want to find our EM value. We can do that given the Nernst equation, right? So we're going to take the Nernst equation for lithium, which is going to be that equals negative 60 over Z. But in this case, for Z, for lithium, it's not going to be 1, it's going to be 3 because the charge, the valency of the charge for lithium is going to be positive 3. So that's just the one thing you got to make sure you don't mess up, because if you do that, then all of your driving force numbers are going to be, totally messed up. So just make sure you do that. So it's going to be positive 3, and you're going to take log the in over the out. So in this case, the in is going to be 14. The out is going to be 140, and that's going to give us a value of 50 millivolts for our EM for lithium. All right. So now the next step is, now that we found the EM and the VM, right? We're going to take our VM to the EM, right? So basically, actually before we do that, let's just look at the direction of the flow, right? So the direction is going to be negative on the interior of the cell because your resting membrane potential is negative, right? Get this glare out of here. Is going to be negative, and then on the outside, lithium is going to be positive, right? So you're going to get the same situation that you did last time. Basically, lithium is going to go inside the cell, and it's going to be called an influx. Anytime you have that, it's going to be called an influx. So then you have an influx of lithium going inside the cell, right? Now let's go ahead and look at our number line, and let's see where we are when we take our EM to our VM to our EM to find out the magnitude of the driving force. So in this case, your EM is going to be 50, which we found there, positive 50. Your VM is going to be negative 30, which was given to us in the question. And we're going to take our VM to our EM, and we're literally just going to find the difference between the two. When I say difference, I mean like you can count the number of spaces in between that and figure out what your value is going to be. So basically you just take this, which is going to be 50 over here, and then this is going to be 30. Add the two together, and you're going to get your driving force value to be 80 millivolts. And that's it. You actually have your answer. Your answer is literally, it's going to be 80 millivolts influx. That's all. That's literally that's it. Like, that's all you have to really do with it. I mean, it was made out to be a lot more complicated than it actually is. But we're just going to go over one more example just really quickly to make sure that we have everything down. And this time we're going to use chlorine because chlorine has a negative charge. And let's see what happens with that. So basically, the next one we're going to do is going to be chlorine. We're going to be given the same resting memory potential. So your inside of your cell is still going to be negatively charged. And let's see how it does, or let's see how it works out with that. So this next one, we're going to be given chlorine as your ion. The VM value that we're going to be given is going to be negative 30 millivolts. And that's going to be given to you in the question stem. And then the values of the inside and the outside of the cell that we're given now are going to be 20 on the inside and 100 on the outside. Okay. So the first thing we want to do is we want to calculate out our Nernst equation to find our EM. So our EM for chlorine is going to be negative 60 over negative 1 this time, because the valency of chlorine is going to be negative 1. And then we're going to take that times the log of in, it's going to be 20, over out, which is going to be 100. So whenever we calculate that out, plug everything in, your EM value for chlorine is going to be negative 42 millivolts. All right. So now this is when things get a little bit tricky, so just watch out for this. And this is also the part where this might not be the actual like scientific way to do this, but at the same time it's going to work. It's going to work every time. Just keep doing it, and just like do a couple practice questions. And there's not many practice questions on this. That's part of the problem. So just stick to what you like figure out here, and it'll work. So basically, the thing is that inside the cell right now, we have a negative charge, right? Because the resting memory potential is going to be negative. Chlorine also has a negative charge. So basically, this is when things get a little strange, and this is when they tried to do all the vectors. Basically, all this is saying is that the inside of the cell is negative, chlorine is negative. If you're moving it down its electrochemical gradient, is the negative chlorine going to want to go inside the negative cell? Like, most likely not. So basically, the simplest way to put this, simplest answer, is that the chlorine is going to go out. So basically, it's going to be an efflux due to the electrical gradient. And it's because, once again, it's weird because you have a higher you have a higher chemical gradient of chlorine on the outside, but the electrical gradient on the inside is going to push the chlorine out regardless. And then the next thing you want to look at with chlorine is going to be, once again, you take your VM to the EM. In this case, the VM that we're given is negative 30. And we want to take our VM to the EM, and in this case, the EM is actually lower. The EM is going to be negative 42. So now what do? Same thing. You just count the number of boxes between the two, and in this case, it's going to be from your VM to your EM, it's going to be 12, right? Because from 30 to negative 42 is just going to be 12. So basically 12 millivolts is going to be your your magnitude for that, and your answer that you're going to get is going to be 12 millivolts of efflux. And watch out, because this is what's going to come up, like as far as like the answer towards efflux, influx. You got to look at where the charge differential is going to be to most likely figure out where the ions are going to be flowing. So just watch out for that, and that should give you your answer right there. And that's it with that one. And there's one last thing that I wanted to quickly note before we finish this off, is that say your EM and your VM are the same. So let's say that you have a VM equals negative 30, and let's say your EM, you calculated it out and you found it to be negative 30. All right, so basically, you do all the steps, you come down to it, and you go all the way through it, and then you have to take your VM to your EM, right, to find out the magnitude of your driving force. Well, if you take negative 30 to negative 30, you have no driving force. It's literally going to be 0. So basically, in this case, your driving force is going to be 0 millivolts, which means you don't have a driving force. It's just going to be nothing. So just watch out for that. Make sure if that pops up, just don't do all the extraneous steps, because that's just going to waste your time. You only have like 70 or 80 seconds or whatever it is. So just make sure that you just watch out if they like try to trick you with that, which they might, because honestly, that's just a very easy way, because you can solve that question in like 20 seconds, which is the point. Ultimately, same thing applies with all these questions. Don't like overthink it on the exam. They're going to be very simple. They're going to be like 2-step questions. And as far as like practicing for it, there's not a ton of practice questions, but honestly, if you just watch this video like 4 times, you should be fine, because this is as hard as it's going to get. So that's about it. But yeah. Hopefully that helped. Hopefully that was a little less confusing than whatever they gave you. But yeah, so hope that helped. Thanks, guys.